This is a video on parametric equations and derivatives. The question states, find dy over dx and d squared y over dx squared. Then find the slope and the concavity at t equal pi over 3. We have the parametric equations. X is equal to 2 cosine t and y equals 3 sine of t. So let's first find dy over dx and recall the formula that dy over dx is equal to dy over dt divided by dx over dt. Well, since y is equal to 3 sine of t, dy over dt is 3 cosine t. And since x is equal to 2 cosine t, dx over dt is equal to negative 2 sine of t. So there's dy over dx. So now let's find d squared y over dx squared. And then recall the formula that second derivative is equal to the derivative with respect to t of dy over dx all over dx over dt. dy dx, we just calculated as 3 cosine t over negative 2 sine of t. And dx over t was just negative 2 sine t. So there's our second derivative. But now we need to use the quotient rule to find the derivative with respect to t of 3 cosine t over negative 2 sine t. So the quotient rule says I take the low, which is negative 2 sine t, times the derivative of the high. The derivative of 3 cosine t is negative 3 sine t, minus the high, which is 3 cosine t, times the derivative of the low, which is the derivative of negative 2 sine of t, which is negative 2 cosine t. I square the bottom, negative 2 sine t quantity squared, and away we go. That's it. So then I got to remember I still divide by negative 2 sine of t. So now let's simplify this. Notice that this becomes a positive 6 sine squared t plus 6 cosine squared t. And sine squared plus cosine squared is 1. So this whole top just becomes a 6. I have a sine squared t and a sine t in the denominator, so that becomes a sine cubed t. And if I take 6 and divide by 8, I get 3/4, and I still have this negative sign. So I get negative 3 over 4 sine cubed of t. And there's my second derivative. Now let's find the slope at t equals pi over 3. So the slope means I just plug in pi over 3 in for t in this first derivative. The cosine of pi over 3 is 1/2, and the sine of pi over 3 is root 3 over 2. So the over 2's cancel, and this all reduces to root 3 over 2. So finally, let's find the concavity at t equals pi over 3. So that means I plug in pi over 3 into the second derivative. So I get negative 3 over 4 times the sine cubed of pi over 3. Well, the sine of pi over 3 is root 3 over 2, and I cube that. And root 3 cubed is 3 root 3, and 2 cubed is 8. 4 over 8 is 1/2, so the 1/2 becomes a 2 on the top. And the negative 3 and the 9 cancel, and what I'm left with is just negative 2 times root 3 over 3. And I'm done with the problem.